In this presentation, I'm going to talk about an IoT based secure vaccine distribution system through a blockchain network. Let's start the presentation. But first, let's see the objectives of this presentation. First, we will introduce with the topic. Then, we will find what was the motivation of the researchers to research on this topic. Then, we'll have a glance over the related works that happened previously on this topic. Then, we would deeply understand the proposed approach by the researchers. Then, we will discuss the results and finally, what were the research challenges that were faced by the researchers during this research? And finally, conclude my presentation. Let's start with the introduction. Introduction. The World Health Organization has classified the novel coronavirus 2019, also popularly known as COVID-19, as a pandemic due to its dangerously infectious nature. The virus, known as severe acute respiratory syndrome coronavirus 2, also known as SARS-CoV-2, leads to severe respiratory distress by limiting oxygen supply to the lungs. COVID-19 is highly contagious, spreading rapidly from person to person. To combat this global health crisis, concreted efforts are underway worldwide. Since its emergence, researchers have been deeply engaged in understanding, exploring, and developing new devices and treatments to address the pandemic. COVID-19 continues to strain healthcare facilities due to its unknown treatment protocols and the vast number of cases. But right now, it's not the case. As the paper was published much further back, the, the text is present tense in that way. Now, scientists, researchers, and healthcare professionals are endeavoring to accurately quantify the situation to provide timely and effective treatment. According to recent estimates from the WHO, there have been millions of confirmed COVID-19 cases, along with significant numbers of deaths and recoveries worldwide. They, these cases span across various countries, including the United Kingdom, Italy, India, Germany, the United States, Korea, China, Japan, and numerous others. Recognizable symptoms such as eye redness, fatigue, fever, throat infections, chills, and respiratory difficulties typically manifest several days after a person contracts the virus. While antidotes have been developed to treat COVID-19 patients, the challenge remains in efficiently and securely distributing vaccines globally to combat the pandemic. Remote monitoring and vaccine distribution schemes have been proposed to facilitate widespread distribution, but there is still a need to explore secure and transparent methods to ensure vaccines reach the required centers promptly. What was the motivation of the researchers? The motivation behind this endeavor lies in harnessing automated techniques to explore innovative and efficient methods for storing and processing recorded data. While the latest techniques offer promising avenues for data management, the sheer volume of data generated by Internet of Things devices presents significant challenges in terms of efficient and secure processing. Moreover, the presence of potential intruders during data transmission can further deter organizations from fully embracing IoT based systems due to security concerns. To address these challenges, researchers have proposed various cryptographic techniques to ensure the security, generation, analysis, and distribution of information among different entities. However, implementing these techniques may incur intermediate costs, time constraints, and additional overhead among involved parties. Furthermore, intermediaries in data transmission processes may exploit vulnerabilities to access and misuse sensitive information for personal gain. In light of these considerations, blockchain technology emerges as a compelling solution, offering a secure medium for transparent and efficient communication among parties. The distributed architecture of blockchain, facilitated by decentralized application, also known as the apps, serves as a robust backbone to overcome transparency, security, and privacy issues inherent in decentralized networks, particularly for real-time applications. By leveraging blockchain mechanisms, the proposed framework aims to ensure the smart distribution of vaccines, integrated artificial neural network schemes, enhance decision-making processes in managing healthcare information. Related work. So this table shows us the related work. Let's go one by one. One approach was self-healing secure recovery and communication system. The mechanism was the proposed system uses a trust-based scheme using single value distribution where the performance and security can be performed using efficient data transmission. The proposed approach is validated through simulation results using IoT-based networks. Another approach was efficient data distribution schemes. A Bayesian classification method was used to estimate the distribution metrics. The proposed mechanism is validated over empirical study analyzed over real data sets with online travel sites. The author claimed that their proposed approach performs better as compared to conventional classification schemes. Reliable data deletion scheme. The authors propose an outsourced policy method integrated with decryption and key schemes. Formal extensive results are demonstrated to examine the efficiency and reliability of the proposed approach. Real-time data-centric mechanism. The proposed system has provided a unique feature of managing and creating the supervision mechanism using humidity and temperature of the carrier. The proposed mechanism has efficiently enhanced the vaccine distribution, supervision, and monitoring in distributed scenarios. Web-based distributed model. The paper focuses on entropy modeling using data vaccine preventable diseases as an example of modeling scheme. Community priority vaccine distribution system. The individuals are grouped into various communities by prioritizing according to their assigned vaccine. The performance of this approach was the first in accurate distribution of vaccines using infected and uninfected people through various network types. Another approach was research issues and challenges. Now, the authors discussed several types of fraud, smart contracts, and identity verification systems by addressing the key management and mining overheads. The performance. Now, a number of potential challenges available for research are discussed in this survey paper. Now, let's dive deep into some of the proposed or related works. One of the related work proposed a self-healing secure recovery and communication system consisting of two layers. The top layer implements access control and deterministic linking through polynomial schemes, while the bottom layer utilizes a trust-based scheme employing single value distribution to measure performance and security via efficient data transmission. Their approach was validated through simulation results using IoT-based network. Another approach introduced an efficient data distribution scheme for IoT-based systems, employing sample-based modeling and Bayesian classification methods to estimate distribution metrics. They validated their mechanisms through empirical studies using real data sets from online travel sites, asserting its superiority over unconventional classification schemes. But another related work presented a reliable data deletion scheme utilizing attribute-based encryption, integrating outsourced policy methods with decryption and key schemes. Their approach efficiency was demonstrated through comprehensive comparisons with data deletion parameters in cloud servers, supported by formal extensive results to evaluate efficiency and reliability. And one of the proposed approach proposed a real-time data-centric mechanism for monitoring vaccine transportation and distribution. Their system utilized humidity and temperature data to create a supervision mechanism, enhancing vaccine distribution, supervision, and monitoring in distributed scenario. Several secure mechanisms have been proposed to ensure a reliable and trusted blockchain mechanism in various healthcare applications. However, few have focused on secure distribution mechanisms such as vaccine report and medicine distribution using blockchain technology. Additionally, existing approaches address computational storage and communication overheads in distributing products and maintaining blockchain among vendors. The aim of this article is to provide reliable transparency and security using blockchain while distributing vaccines without increasing communication costs or delays among the vendors. Proposed approach. Now, this flowchart or a schematic diagram represents the proposed approach. System models of the design mechanism, which is illustrated in the previous diagram, comprises a vaccine supplier company headquartered at location A with vaccine supply units situated at location B. Subsequently, these suppliers distribute vaccine to various locations, including hospitals, businesses, and other organizations. Secure and efficient vaccine distribution is facilitated through a level-wise blockchain network. This distributed blockchain architecture ensures reduced complexity, storage requirements, and size for validating each data unit. Furthermore, to monitor all activities of participating entities, suppliers have employed a permissioned blockchain as depicted in the figure 1. The initial implementation commences at the headquarters, which possesses the authority to monitor every activity and progress at each level. Moreover, healthcare facilities, businesses, organizations, distributors, and medical stores maintain independent blockchain networks to monitor and track progress among various entities. Proposed approach, working processes of the proposed approach. Now, this diagram is the architecture of the blockchain network of the proposed approach. And this is the vaccine distribution mechanism using the blockchain. The efficient organization and management of the proposed blockchain systems are divided into 3 stages. Stage 1 involve the headquarter and distributors blockchain, where the medical stores, distributors, and headquarters collaborate to form the stage 2 blockchain. Additionally, healthcare systems along with patients' details and headquarters constitute the stage 3 blockchain. The headquarters serve as the central entity connected to all levels to trace each activity, ensuring a secure and transparent system. The blockchain architecture, including the 3 stages, is illustrated in the previous figure. In stage 1, the genesis block of the network is established by the headquarters between the distributors and the headquarters. Distributors initiate the supply process upon receiving orders from various organizations or medical stores, maintaining transparency by recording all supply requests in stage 1 blockchain ledger. Moving to stage 2, an extended blockchain is maintained among distributors, headquarters, and organizations upon the delivery of requested vaccines to medical stores. Automatic notifications are generated informing the headquarters of the supply process. For instance, upon departure to corresponding stores, headquarters receive notification A regarding the supply of X vaccine units. Subsequently, medical stores send notification B upon receiving the vaccine units. The stage 2 blockchain network reflects the total vaccines produced, ordered, and delivered by the distributors and firms. In stage 3, which represents the edge level of the blockchain, patients and healthcare systems details are included. When vaccines are received by a healthcare system, a notification is sent to the headquarters. Upon reception, notification C is sent to headquarters. This stage addresses various associations involved in the blockchain. Suppose there are 4 entities: the headquarters, responsible for creating the Genesis block and overseeing progress; distributors D1 and D2, tasked with delivery vaccines upon receiving order requests from stores; and medical stores serving as the third entity, distributing vaccines to healthcare firms. Healthcare firms ultimately receive the vaccines to vaccinate patients as per their demand. The tabular representation of all 4 entities is depicted in figure 3. Transparency among entities. Upon receiving the delivery of 100 units of vaccine from the healthcare firms, the headquarters initiates the setup of a Genesis block and instructs distributors D1 and D2 to distribute the vaccines. Distributor D1 is tasked with transferring 60 vaccines, while D2 is assigned to deliver 40 vaccines. Cheating or altering the units would prove extremely difficult, as all activities can be easily traced by the headquarters. No distributor has the capability to increase or decrease the delivery units without administrative permission. Headquarters HR generates the Genesis block of transmission, serving as the first block between HD1 and HD2, which is broadcasted to available ledgers. HR contains details of all distributors, medical stores, and healthcare systems. After receiving HR's request, distributors V1 and V2 commence delivering the ordered vaccine units by adding another blockchain to the existing network. D1 and D2 ensure transparency by including medical stores in their blockchain. Medical stores may further enhance transparency by adding healthcare systems to their blockchain, generating a new hash and appending it to the previous one. This blockchain configuration ensures that all stores and healthcare systems are properly placed, enabling stores to view each other's details. Finally, healthcare systems XYZ receive the vaccines, maintaining a blockchain among themselves to check each other's delivery details. Performance analysis. Now, this is the performance analysis. The performance analysis of the proposed blockchain mechanism is conducted in recent research papers, where vaccines are distributed through a blockchain network to the intended patients. In these analyses, an IoT-based network is employed over 3,600 epochs with varying durations at different levels. Synthesized data comprising 1,000 vaccine units ordered and requested by various entities within the blockchain network is generated for verification purposes. Table 2 presents the obtained results compared to existing schemes. The data analysis encompasses true generated reports representing accurate results and altered data. Additionally, a malicious environment is created to assess data alteration within the network, facilitating a comparative analysis with the baseline mechanism. True generated reports refer to the total number of vaccines orders placed by healthcare systems and the actual orders delivered by the distributors. On the other hand, data alteration denotes the number of reports generated and subsequently altered by the intermediate entities while placing orders among distributors and healthcare systems. This comprehensive analysis aids in identifying accurate and altered reports within the environment, thereby evaluating the effectiveness of the proposed approach. Results and discussion. So the following graphs show the results and show the results. Figure 4 or the previous figure illustrates the comparison of two security measures, true generated report and altered data between the proposed and existing phenomena. Figure 4a displays a graph indicating the number of true reports generated by the proposed approach. In the proposed phenomenon, the generated reports are consistently true and accurate compared to existing mechanisms. This accurately is attributed to the maintenance of a blockchain architecture among multiple entities, ensuring transparency and correctness in reports communicated by IoT devices. Additionally, the generation of blockchain data entails less delay and complexity due to level-wise block generation, which mitigates storage maintenance in the system. Furthermore, the proposed phenomenon is evaluated concerning the data alteration process as shown in figure 4b. Any alteration in the number of generated units by a malicious intermediate entity can be promptly and easily detected by the proposed scenario. Detecting altered data during the communication process is crucial for maintaining the integrity of the blockchain database. The proposed phenomenon exhibits significant improvement compared to conventional approaches, primarily due to the utilization of blockchain technology. Research challenges. Numerous researchers have proposed various cryptographic and blockchain-based security mechanisms for a wide range of smart applications. However, before integrating these mechanisms with any technique, it is essential to address several blockchain issues. The following are some of the challenges and issues that need to be focused on before further integration with any smart-based application. Verification delay. The time required to validate any new block before adding it to the existing blockchain is a significant parameter that needs attention. Notes that taking more time to verify blocks may expose the network to various wireless security threats such as authentication, man in the middle, and handoff attacks. Special node selection. Another major issue is the selection of nodes to validate or verify incoming data. Trusting mechanisms are required to identify the legitimacy of each node that may participate as a special node for validating incoming blocks. Network scalability. Thus, number of entities participating in the communication or distribution mechanisms can vary depending on application. A network with a large number of entities may experience significant verification and validation delays, as well as increased storage and complexity. Double spending threat. Distributors may attempt to earn money from both parties by promising the delivery of the same package to different locations. Therefore, it is necessary to introduce a secure and accurate mechanism to address this issue. Conclusion. Now, conclusion is yes, using blockchain for vaccine distribution is an effective tool which brings efficiency into the system. But there are issues that needs to be challenged, and this paper effectively articulates those challenges and asks other researchers to solve them. Thank you.